Welcome, everybody. We will be waiting for folks to join. Meanwhile, if you want to write in the chat where you're tuning in from, and if you're dressing up for Halloween, what will you be? Or if you aren't dressing up for Halloween, what was your favorite Halloween costume you've ever had? I'd love to see your answers. I have some folks from Orwell, and Rutland, and Richmond. Welcome. Not seeing any Halloween costumes yet. I hope to hear about those. Welcome from Walcott, White River Junction, Essex, Middlebury, Chester. Oh, that's amazing. A door. Must have been quite the engineering feat. Oh, we have someone tuning in from Colorado. Montpelier, Middlebury. Another one from Orwell. Excellent. We'll wait a few more minutes while people trickle in some more. Um, and if you're just coming in, we're asking where you're tuning in from. And if you're dressing up for Halloween, what's your costume going to be? And if you're not dressing up this year, what was your favorite Halloween costume you've ever had? We have Albany, Danville. Welcome. Pittsburgh, South Burlington. Oh, we have a hand up. Lance, can you write your question in the chat? Or you can put it in the question and answer field if you don't want to share. All right, I think looks like people have mostly come in so far. So welcome to the Weatherization Wednesday webinar of the Button Up Vermont campaign. We'll be recording this session and we'll be providing the recording to all registrants after the webinar. It will also be available on Efficiency Vermont's YouTube page afterwards. So welcome to Why Heating Your Home Isn't as Simple as You May Think. My name is Mary Catherine Graziano. I'll be doing the introduction and discussing the rebates. You will be mostly hearing from our expert, Steve Spatz, and Bruce will be in the background answering your questions. Next slide, please. So a little bit of housekeeping. Your video and audio has been turned off. Please type any questions you have in the chat. We will be answering them as we go along. That'll be Bruce and Anna in the background. If you need accessibility features, click the square box with the 3 dots in it that says more to turn on auto captions or other accessibility features to help you access the presentation. And this webinar is being recorded and we will share the video and slides afterwards, like I said earlier. Next slide, please, Steve. So what is Button Up Vermont? Button Up Vermont is Vermont's annual campaign to help Vermonters prepare for winter. It's supported by a broad range of statewide and regional organizations that work with communities to help residents reduce their energy costs through weatherization and heating electrification. Next slide, please. And Efficiency Vermont is one of the primary button-up partners sponsoring the campaign and this webinar. Next slide, please. So what will you learn today? Today we're going to go over heating systems, water heating systems, resources and available rebates, And at the end of this presentation, we will have about 10 minutes for question and answers, but you can always type your questions in the chat. I will now turn the presentation over to Steve. Thank you, Steve.
All right. Thank you, Mary Catherine. Appreciate that. Appreciate everyone joining us here today. So what we're going to be covering today is kind of just a primer on heating and cooling equipment, what types of equipment are you're going to see in your home, helpful ways to identify some things that maybe you're not familiar with about the equipment that's in your home, and then discuss some ways to integrate heat pumps and other items that maybe you could do or things you could do to your existing system to make it more efficient and/or make your home more comfortable, which is the key thing here we're trying to do is create comfort. So just to level set a few terms that you'll hear today that we'll be discussing, HVAC. So that's the overarching umbrella of the heating, cooling, and ventilation. So you hear that term used a lot in regard to the overarching technicians and trades and equipment that provide heating, ventilation, and cooling in the home. A zone, that's a term used to define a space or an area that can be individually conditioned from other parts of the building. So you can have different temperature controls and settings in different parts of the house. Ductwork is the series of piping that moves heat and/or cooling energy, hot or cold air, through the home by way of heating with a furnace. It is one of the distribution system types for conditioning homes. The other type of distribution that is common in our homes is hot water piping or hydronic heat, and that is moving of heat energy through piping and tubes and radiators and things like that through the home. Both of those are considered distribution types for whole house systems. And also to level set, the term that is used by the industry to define the capacity and output for heating equipment and cooling equipment is the British Thermal Unit, the BTU. So 1 BTU is the amount of heat energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. This is the common language that is used, the common term that is used to both understand the capacity of a system needed for a home, what the home's rate of loss of BTUs will be during the winter months and need to be replaced with some sort of heating system. So this is kind of the basis for what we're talking about when we're looking at different equipment types. Equipment types and fuel types as well too. So here's a chart that shows you the common fuel types that are used for heating, and the cost per unit are a little bit out of date. They're kind of, a little bit, those prices can vary obviously year over year. But just as a comparative here, what we're looking at is the capacity in each type of fuel, how many BTUs that fuel has, and what's available to put into the home. So that third column there, each in an equivalent unit here of fuel, you can see how many BTUs there is per comparative unit of fuel. Electricity has a lower amount per kilowatt, but a kilowatt would be equivalently smaller than a gallon of a fuel oil. But you can see here comparatively, what we're talking about per unit of BTU capacity. And this matters when you're considering what type of system to use in your home, what type of fuel to commit to for heating, and also the efficiency of the type of fuel as well too. Different types of fuels will burn more cleanly and more efficiently than others. Most notably, the difference between natural gas and propane versus heating oil. You can extract more of the potential heat energy out of natural gas or propane than you can out of a gallon of heating oil. So those are just some comparatives here to be considered of as we start to talk through equipment type. A critical aspect of a well-performing and well-maintained heating system is one that's properly sized, appropriately sized for the building. The methodology in the industry that's used is what's called a heat load calculation is done for the home. And this is where there is a formula for taking the characteristics of the home. So how much insulation is in the walls, roofs, with the windows, the air tightness of the home, how leaky the house is. It depends on the climate zone, where you are, what the annual heating degree days is called, meaning how much heat, energy a building would need depending on the season. And all of that information is used to then calculate what the load of the house would be, meaning that on a day in January where it's 15 degrees outside, how much heat energy in BTUs is that house losing at that time? And then that helps determine what size heating equipment needs to be put in place to make up for that heat loss. It's very common to see wildly oversized heating systems in homes. And when that is the case, that heating equipment is going to run inefficiently. It's not going to burn the fuel as efficiently as it could. It'll also come on and off often and can lead to big swings in temperature in the home. It can also wear out the equipment faster because of that mechanism. So it's really critical that when you're putting appliances into the home for heating and or cooling, that they're appropriately sized to the need of the house. So let's just talk about what the common types of heating equipment you're going to see in any given home. So essentially, there's 4 different types that we'll be talking about. A furnace heats air and moves it through ductwork. The ductwork is the distribution system for that heating appliance. A boiler heats water and moves that through piping through the home, and that can have a variety of different outputs in the home. It can be baseboard, it can be radiant floors, it can be panel radiators. There's a variety of different ways that the heat energy can be emitted into the room. Space heaters are essentially any type of appliance that would be just conditioning a space that it's in. This is not when we talk about a space heater, we're not talking about something that has any sort of distribution connected to it. There's no piping moving heat from that piece of equipment to another part of the house. Wood stoves and fireplaces are kind of considered a space heater in that regard too, although many of us use wood stoves to heat our whole homes. But the idea here being is that you're creating enough heat energy that it will kind of heat the space that it's in and or a larger space depending on how much heat energy or BTUs that stove can put out. But those are essentially the 4 different types of appliances that we'll see in a typical home or building. So furnaces, again, the mechanism here is that you're burning fuel in the cabinet and the air handler unit. And then there's a blower fan inside that furnace that is moving air across that hot heat exchanger where all the combustion gases and the burning of the fuel moves. So that type of system is going to it has the capability to provide both heating and cooling, depending on what equipment is connected to it. With the furnace and with the ducted system, you're kind of limited to what you could do to zone the system, meaning that essentially it's one large connected duct system, and you really can't adjust temperatures from room to room or zone to zone in the home. You're kind of looking at a consistent temperature setting for the whole system with the furnace. And as noted here, this more common what we have in our homes are furnaces that are just doing heating, but an existing furnace, depending on the type, or modern new furnaces can have the capacity to integrate a heat pump for cooling and or heating into that duct system. Conversely, boilers, again, are heating water versus air and moving it through piping throughout the house. A boiler is only going to be able to have the capacity to heat the home. You can't run cool or chilled water through the piping and the baseboard and the radiators in the home. So a boiler is only going to have the capability to do heating. A big difference between a furnace and a boiler is that when heating with water, water has a much higher capacity for carrying heat energy than air does. So the equivalent, distribution size of what needs to be moved throughout the home is much, much smaller than the size of the ducts you'd need to move that equivalent amount of heat via air. So smaller physically smaller infrastructure. And typically modern gas boilers have a higher efficiency rating than any type of furnace would. But we're talking the potential of equipment here of being in the upper 90s for efficiency. There is the possibility with modern ground source and or air source to water, air to water heat pumps to integrate a heat pump into a hot water distribution system and or with the boiler, an existing boiler, to take up the heating load. Again, you can't do cooling in these situations, but heat pumps can be integrated to create hot water that can be integrated into these system types as well. There's a lot of variables at play for if and how that could work, and if it's a possibility or viable with an existing system, but the technology exists where that is a possibility. Space heaters can be a variety of different things. The picture here is a plug-in electric space heater. These can be pretty common in our homes when we have a room that's just not quite comfortable enough with the whole house system running. Maybe there isn't enough ducts into that room because it's an older home. The ductwork just can't reach there, or a lot of windows in a room that makes the space colder than what the whole house system can provide. Or a space heater can be used in place of the whole house distributed system. If there's no distribution to a section of the home, maybe that room is heated by a space heater. And these can be propane. They can be, a heat pump is considered a ductless wall-mounted heat pump would be considered a space heater because it doesn't have any distribution connected to it. So space heaters can be a problem solver for low loads or small spaces and supplemental heating throughout the home. Wood stoves, again, are in our neck of the woods, can be used as a space heater and used to supplement the use of the whole house system. Or depending on the placement of the wood stove and how people, choose to use it, it can be used as your primary heating system for the home. Again, it's not distributed, so you're only, getting the benefit of the heat energy in proximity to where the stove is located. A huge range of efficiencies and safety essentially with wood stoves. The common installation for a wood stove is it's just drawing air from within the home and for combustion and for draft of getting those gases out of the home or out of the fireplace or box. And so it's something to consider if you start tightening up your home and making changes to the physical infrastructure of the home by way of weatherization, to be mindful of the needs of a wood stove in the home because they can use a lot of air for combustion. The type of wood that you use also has a factor on how much heat energy you're going to get out of the stove and maintenance needs as well. Fireplaces. Fireplaces were, what our forebears used as their way of conditioning their home and heating their home. And usually the larger the mass of the masonry of the fireplace in the middle of the room, the more heat energy you got out of it. And the mechanism there was that the fire in the hearth would be heating up that mass of stone and masonry, and that was what would be radiating heat into the room. But more commonly, what we have in our homes are, a fireplace in the room on an outside wall, and it's just the hearth open to the room. Uh, Almost all the heat energy from a fire burning in the hearth is going to go up the chimney. You'll get some comfort from it in the room in proximity to the fire, but as soon as that fire dies down, you're sucking more air out of the house up the chimney than you would be without that fire going. So modern requirements for fireplaces also require that any fireplace have an airtight glass enclosure to the firebox. You can't have an open hearth anymore to the room. And there's a variety of reasons for that, and valid reasons and good reasons for that. But using or considering a fireplace as a heating appliance for the home is not really something that we should be looking at them to do. I'll stop here for a quick second and see if there's any questions, Bruce, that we should address, or we can wait until the end.
I think we're all set so far, Steve. Thanks.
Okay, thank you. All right. The other important part of heating appliances is venting those appliances. anything that's burning a fuel is creating combustion byproducts that you do not want in your home. We need to remove effectively and all of the combustion gases from the burning of the fuel. And this is wood, propane, oil, anything, any type of fuel that is being combusted in an appliance needs to be vented out of the home. Uh, Again, as I noted with the wood stove example too, depending on the type of heating appliance in the home, some will be affected by negative pressures inside the house, meaning that um, older types of furnaces and boilers relied on air from within the home to be available for combusting of the fuel and for getting the venting of the gases out through the chimney. Those are no longer, that type of system is no longer allowed by code. But those are systems where you have to be considerate of not putting in like a huge commercial grade kitchen rain hood as part of a kitchen remodel that moves a tremendous amount of air, sucks a tremendous amount of air out of the house. That type of setup with an older, what's called atmospheric furnace, can draw those combustion gases back into the home. So these are things to be aware of as you make changes to the home, and I'll share some examples with you so you can start to identify what those types of venting might look like in your home and what to be aware of. So there's essentially three different mechanisms for removing those combustion gases from the appliance. There's atmospheric venting, which is a chimney. So essentially, if you have a masonry chimney in your home and your appliance, your furnace or boiler is piped into that, that's the type of venting you have for your equipment. Power vented systems use a fan and motor in line with the exhaust pipe from the stove to induce draft to create suction and essentially pull the combustion byproducts out of the appliance and remove it from the home. And then sealed combustion, where the system is drawing its air for combustion and draft from the outside of the building and then venting directly to the outside as well. So let's just take a look at what these look like. So again, atmospheric vented systems, again, essentially, if you have any type of masonry chimney or metal chimney that is going up beyond the plane of your roof and your appliance is plugged into that, that type of system is considered an atmospheric system. It's relying on air from within the home for the combustion and for the draft. It's relying on warming up the chimney to create suction and create draft for the gases to get out as well too. A masonry fireplace or masonry chimney that is on the outside of a home, as in this picture here, can be harder, create conditions that are harder for the appliance to draft at certain times when it's very cold because the masonry of the chimney is cold enough that you're not getting as much draw up that chimney with the hot gases as you would if that masonry chimney was inside the house and warm to the ambient conditions. So part of the dynamic at play too with different types of appliances and effects on efficiency is that with an atmospheric vented system, a lot of the heat energy of burning that fuel ends up going out the chimney. And this is part of the mechanism for how the drafting occurs is because there's enough hot gases going up the chimney that creates the draft, which means then that more of that heat energy is not going to heat your home. You have more extraction of heat energy with the other types of vented systems, specifically sealed combustion. But power venting, you can see power vented appliances. These can be retrofit onto older furnaces or boilers. They can be designed and set up that way from the get-go, from the factory. But essentially for the draft here, you're using a fan and with a motor on it that is, again, when the furnace comes on and it's burning fuel, that motor comes on, it creates suction and it pulls the exhaust gases out of the home. Typically, these are vented through a sidewall or through the basement wall to the outside. They can be vented through the roof as well too. But those are the legacy types of systems and venting, and many of us still have those in our homes. And the more modern types of vented appliances, which again are required by code now. So if you are replacing a furnace or boiler and putting a new furnace or boiler in, the new equipment needs to be sealed combustion. And the benefit of the sealed combustion is that it's not relying on any air from within the home for combustion or draft, so it won't be affected by exhaust fans, range hoods, things like that. You get better heat extraction out of the fuel by the mechanism of this type of system as well too. So more of the potential heat energy from the fuel goes to heating the home than it does going out the building. These are vented with PVC pipe. And so these types of systems, that tells you how much heat energy is being extracted to heat the home because the air temperature of the combustion gases going out through that PVC pipe are cool enough that you can use PVC and not melt it. So these are just two examples of what that would look like in modern equipment. A furnace with those two PVC pipes, one for supply, one for exhaust, and then the boiler on the right. So these types of systems are going to be typically vented out, again out through a sidewall in the home. Gas heaters, space heaters, this example here in this picture, it looks like a wood stove, but it's actually gas. You can also commonly find these as wall hung units as well. Rinnai is one of the bigger names and manufacturers of that type of equipment, and those can be, floor mounted and on directly to the outside wall. These can be vented or unvented. Unvented. You do not want an unvented one. And if you have an unvented one in your home, you should consider replacing it or removing it because you are combusting fuel. You're burning propane, and the byproducts of that combustion then in an unvented system are just going into your home. So that's not ideal. We don't want to be breathing in carbon monoxide and other noxious fumes that come off of the burning of the fuel. So any sort of gas space heater should be direct vented to the outside, and any modern equipment would be. Similarly for wood stoves, fireplaces, now again by code, if you're using or installing a wood stove or building a fireplace, the combustion air for the burning of the wood needs to be drawn directly from the outside and brought directly into the firebox. So if you have a wood stove, modern wood stoves have a piping setup to install with the wood stove where you bring a duct directly to the outside and that pipes directly into the firebox. So again, trying to minimize, if not eliminate, the risk of any potential negative pressures in the home, sucking combustion gases back into the house. If you have an older wood stove, this is something to be aware of and consult potentially with a chimney or stove person to make sure that you don't have any issues where the system could backdraft into the home. Again, especially if you're doing other work on the house, such as weatherization, that may tighten up the building, or putting in new ventilation exhaust systems into the home for bathrooms or range hoods, et cetera, that could have an impact as well. So these are just things to be aware of when you're looking at your systems in your home. And then that brings us to the fact that in any home with any type of combustion appliance, you definitely need to have active smoke and carbon monoxide detectors in the home. The number of them and where they're going to be placed is going to be dependent on the layout of your home. But you definitely want to have this equipment in your home, maintain it, know that it's working, test it when on a regular cycle as well too. Most CO and smoke detectors now are either going to be hardwired, meaning that they're electrically connected to your electric system. They don't rely on batteries. Or if they are battery powered, they have usually an 8 to 10 year battery that's installed into the unit. So they don't require changing of batteries, but they do require testing to make sure that they're working. So definitely a critical thing to have in any home. All right, any questions at this point? Okay, I'll keep rolling here. And now heat pumps, probably what a lot of you came here to learn about the application of heat pumps. We will be doing another webinar in 2 weeks, more specific on heat pumps and getting into it in more detail. But heat pumps are another option for heating and or cooling your home. And Heat pumps do not combust any type of fuel. They are not a fuel burning appliance. They move heat energy by way of the refrigerant cycle. And so they're piped together in an indoor unit and an outdoor unit by way of refrigerant piping, a supply and a return line. And in that copper piping is carried refrigerant, and refrigerant exists both as a liquid or as a gas, depending on its phase, its temperature, and its pressure. And that's how, without going into extensive detail here, how heat pumps work. The refrigerant is able to absorb heat energy from air or water or the ground, and then move that heat energy via the refrigerant cycle to an appliance inside the building that is then exchanging the heat from that refrigerant in the piping by way of either moving air across the coil, the hot refrigerant piping, and moving warm air into the room, either by way of it being a ductless head or in a furnace, or transmitting and heat exchanging the heat energy of the refrigerant in the piping to water and heating water by way of this mechanism. So that gives us essentially air-to-air heat pumps where you're taking the heat energy from air as the source, and you're moving that heat energy into the room, into the building by way of air. Water or ground to air, and then water or ground to water, and then finally air to water. So these are the four different types of applications for heat pump equipment for conditioning buildings. So just to explain how the application of heat pumps come into the home, because there are a variety of ways that they can be integrated into a home and used for different needs, either as, conditioning a space or to condition the whole home. But what we mean when we say a whole house system is that you're talking about an appliance that is providing conditioned air or water piped throughout the entire building. So you're not just creating space heat, but you're moving that heat energy throughout the entire building. So as an example here, the image on the top left is a ducted system where you have what's called the air handler, and that's where the heat exchange occurs, and where the blower is that would be moving the heat energy through a system of ducts piped throughout the house, room by room, and designed appropriately to move the right amount of air into each of those spaces. And then alternatively, with a boiler or a hydronic heating system, this is an example of a piping schematic of what it might look like in a typical home where you have the heat source of the boiler, and that could be a heat pump or it can be a gas boiler. And then the piping that's connected to that moves that heat energy via water throughout the home and into different types of emitters that are in the building: baseboard, panel radiators, convective radiators, etc. So that gives us basically three different ways of conditioning a home with heat pumps. So for forced air, this can be a heat pump integrated into an existing furnace, potentially, or a standalone for a ducted heat pump to move air into the room or throughout the building. Integrating heat pumps into hydronic systems, moving that heat energy by way of water, and then ductless heads. So ductless heads, again, are kind of what would be considered a space heater. Right? There's no distribution system connected to it, so it's just conditioning the space that the piece of equipment is going to be in. Ductless wall-mounted heat pumps are probably the most common type that most of us are familiar with and most of us see or think of when we say heat pumps. These provide the benefit of both doing two things or having the potential to do two things. One, they can be used to provide heating and cooling in a space that, again, either didn't have any distribution from the whole house system to that space previously, or was just a hard to heat or cool room. So they can be used in that manner. They can also be used to take up load from your existing whole house system, where you rely more on the heat pump for more of the heating needs for the home than you would on the furnace or boiler. You can leave the furnace or boiler turned down or off during certain times, or depending on how you want to use the heat pump. So this is, again, probably the most common pathway people start to integrate heat pumps into their home. single zone one-to-one units are by far the most efficient, meaning that the best performance you're going to get out of a ductless heat pump is one indoor unit connected to a single outdoor unit, one pair. You can get models that have one single outdoor unit that are connected to two, three, four indoor heads. But those types of systems oftentimes can create some comfort issues, and they may not run as efficiently, or they won't run as efficiently as single zoned, single paired units. So just something to be considerate of as well too. Now, ducted systems, again, this is a way to take the heat pump and the refrigerant process and move that heat energy throughout the whole home, and either create zoned heat by way of putting multiple air handlers. That's what these boxes here would be called, in different parts of the home. So you have different zones conditioned by way of heat pumps, ducted heat pumps. Or you can integrate a heat pump potentially into any modern furnace. You have the opportunity of putting a heat pump refrigerant coil into the box or the air handler of the existing furnace. And then that can be used for your primary heating or supplemental heating to the furnace itself. Um, so there's a variety of options and ways you can utilize this type of equipment, both in an existing home and for new. For new construction, this type of equipment can be used as the only heating system. You know, the house designed around the use of a ducted heat pump. You don't need, in that scenario, a furnace or boiler, propane or gas, or otherwise furnace or boiler to work with it. The heat pump can take the load itself. So there's a variety of ways to utilize these. One thing to be considerate of compared to what a fuel-fired furnace will provide, the air temperature moving through the ducted system in a fuel-fired furnace is usually going to be between 120, 130 degree air temperature, whereas a heat pump is going to be delivering 85 to 100 to 110 degree air through that duct system. So it's enough heat energy to satisfy the thermostat in the room and keep the room conditioned to a set point, but you may not notice the warmth coming out of the ducts, out of the registers, as you would if you're using a fuel system. And then finally, hydronic distribution. There there's equipment coming to the North American market, air to water equipment coming to the North American market that can produce water temperatures that are closer to being equivalent to what a fuel-fired boiler can create. Most types of hydronic distribution in homes, in existing homes, baseboard heat primarily, relies on warmer water, 140 to 160 degree water typically. Heat pumps, whether it's a ground source or air source heat pump to water, is going to create ideally 120 degree or less water temperature. There is baseboard and other types of hydronic distribution equipment that is designed around low temperature water. And if you're building a new home, that would be the way to utilize the system. The heat pump into the system is use the heat pump and design a low temperature delivery system, distribution system throughout the home. So that is where the heat pump is designed around that type of delivery. So in an existing home, there may or may not be the potential to integrate an air to water or a geothermal heating system to be used with the existing distribution. In those scenarios, you might have to change the distribution that's in the home and put in different equipment or add more equipment to that. But these are becoming more common, both, if geothermal systems can be used for either hydronic heating and or forced air. But these are ways we're seeing the heat pump equipment utilized more and more in our market. Most often in an existing building, the integration of heat pumps is meant to displace a portion or the majority of the heat load that is being made up or met by the fossil fuel system. So in that scenario, you have, the existing conditions are you have a furnace or boiler heating the entire home, and then integrating heat pumps either by putting in one or more ductless units in the home or integrating a heat pump into the furnace or boiler, is that you're taking up a significant load of the heating with the heat pump while still retaining the existing system that's in place. And so that can be necessary because of the design of the home, the heat loss of the home, where the heat pumps might not have the capacity to fully heat the home when it's below zero out. Any modern cold climate heat pump has the capacity to maintain its temperatures of delivery at 0 degrees and better. Their output declines as it gets colder out below zero, but they still work and they still will be creating heat energy. The question then becomes, is it enough heat energy that the building needs to keep the occupants comfortable, or do you need to start to use the existing system to bump up the temperature or replace some of what the heat pump can't take on? So that's the typical model for how you'd see heat pumps integrated into an existing home. Again, if you're building a new home or completely redoing the system, you can specify, design, and install a whole house heat pump system that is not reliant on any sort of fossil fuel as a backup. Quick check for questions. And then we'll get into our last section here on water heating. All good, Bruce?
All good, Steve.
Okay, thank you. Finally, water heating. So there are 5 essentially typical types of water heaters you'll see in any given home. And these can either involve a storage tank or not. So electric resistance water heaters, so it's a storage tank with two typically electric resistance elements heating the water. A tankless coil is something you'd find in a boiler, as well as an indirect fired water heater. Both of those types are you're creating your domestic hot water off of the boiler that's being used to heat your home. And we'll talk about the difference between those two. Instantaneous or tankless water heaters, they're usually a small wall-mounted appliance, and they're either electric or propane. And these just create immediate water when the call for water comes on. So when you turn on the faucet, it essentially turns on the water heater, and the water heater runs to heat the water while you're using it. So there's no storage there, no storage capacity. And then finally, a heat pump water heater, where we're utilizing the refrigerant process for heat transfer to generate the BTUs needed to heat your domestic hot water. And that's an electric type system. But most commonly, a lot of us have electric resistance water heaters in our home. Previously, GMP and or Central Vermont Public Service rented water heaters, or you own the water heater. But again, it's a storage tank, so you're creating a tank of water stored for when it's needed, and they can vary in size from 15 to 20 gallons up to 120 or more gallons in capacity. And the mechanism here is that the water heater just runs on its own to maintain the temperature that it's set at. So it keeps that tank of water at that set temperature, usually between 120 and 130 degrees. And that's what it does. And so then when you turn on the faucet and it draws down the BTUs in the tank, then the electric elements come on to bring the temperature back up. So very common type of appliance for heating domestic hot water. Alternatively, if you have a boiler and you have a hydronic heating system in your home, in those scenarios, it's common to use the boiler for your domestic hot water. What's called a tankless coil is essentially a loop of piping in the body of the boiler itself. It usually sits at the top of the boiler. That is the zone for your domestic hot water. So essentially, when you turn on the faucet and you're running hot water, or turn on the shower, the boiler is going to run to heat up that water and then pipe it through the house. So very good recovery, pretty much consistent hot water when you're running it, but there's no storage capacity there. There's really usually only like a gallon or two of water stored in that piping that's available and hot before the boiler needs to come on and heat more water to move through the house. It can be pretty inefficient because it's going to be less efficient than the boiler itself for just the heating pathway. So oftentimes, if you have a boiler, what you see is this, an indirect fired tank, which is a storage tank. So it works similar to the electric resistance water heater where you're storing a capacity of water, again, anywhere from 20 to 120 gallons. And the boiler is running to maintain the temperature in that tank. So that'll just, the boiler and the water heater communicate. And when the temperature drops below the set point, the boiler comes on and heats up that tank of water. As you use the water and draw down the BTUs in the water, the boiler will come back on to heat it back up. So it's essentially just another zone off of your boiler, but used for domestic hot water. The efficiency of an indirect water heater is going to be less than the efficiency of the boiler. So if you have a 94% efficiency boiler, your water heating is not going to be 94% efficiency. It's going to be, significantly less because of the, separation and piping between the two. Instantaneous or tankless water heaters, again, as noted, they're either going to be gas or electric. These can be challenging to use as whole house systems if it's not close to where the need is for the hot water in the home. So meaning that, if you have a larger home and you're piping water 75 feet away from that instant water heater to the source of where you need it, these systems might not work that effectively or as effectively as other options may. Water quality in the home from the well or from the public utility has an impact on the longevity of the equipment. If you have hard water or rust or scale, it can really ruin the heating elements in this type of heater in short order in a matter of years. So it's important to test your water quality before considering using one of these in a home. But they can also be used to kind of solve some problems as well too for maybe portions of the home that are far away from the heat source for your domestic hot water. You could choose to put one of these in near where you need it to supplement the larger system. And then finally, heat pump water heaters. So a heat pump water heater is a storage water heater. It's a tank. And again, sized based on need for the home. These are going to be usually between 50 and 80 gallons. There's a few on the market that are 120 gallons. This is an easy retrofit in an existing home that you can use to replace an existing water heater, an existing electric tank water heater, and or a tankless water heater, I mean, indirect water heater. For the only consideration to be aware of when wanting to put one of these into a home is the height restrictions because of the fact that the heat pump coil that's being used to heat the water sits on top of the storage tank. They're taller than your typical water heater would be. Airflow is also an issue here as well too. You need air to be moving through and across the refrigerant coil on top of the water heater, so you can't put these in a confined or constrained space. They can be run either just with the heat pump only, or there are two electric resistance elements in there as well that can back up the heat pump as or if needed to supplement the heat pump. But this type of equipment, when using the heat pump as the mechanism for creating the hot water, are highly efficient. You get more heat energy out of the kilowatt being used to create and run the system to run the refrigerant cycle than you would with a traditional electric resistance water heater or any other type of water heater. So definitely the most efficient option available on the market. All right, so that kind of covers the equipment, the technology, the things to be considered. Mary Catherine will touch base with you here about what to do from here, our options for how to explore your options, where to go from here, and then also what Efficiency Vermont rebates are available.
And we actually had a question in the Q&A where somebody wanted you to discuss the electricity use to run the heat pump at very cold temps, and they specifically wanted you to answer that question. and then I'll go on to my component.
Okay. So is the question specifically how do cold temperatures affect electrical consumption when running a
Yeah,
heat pump? Okay.
yeah,
Um, the electrical consumption is going to be correlated to just how long the equipment's running. It's not like the heat pump necessarily runs harder when it's colder out. The idea of what makes a heat pump equipment and the refrigerant equipment run efficiently is that it comes on and it's meant to just slowly modulate its running. It's the system depend to modulate to the need for the house. So it doesn't come. You don't want the equipment to just come on and off, come on, heat up the room quickly, meet the set point, and then shut off. You want the heat pump to come on and just run at a moderate capacity consistently to maintain the temperature in the room. Um, the colder it gets outside, the less BTUs the system will be putting out. But I mean, like I said earlier, any cold climate rated heat pump, anything that Efficiency Vermont offers and rebates on, is going to need to maintain its full heating capacity at least a 200% efficiency equivalence at 0 degree outdoor temperature. So you're still getting more BTUs than the electricity used to run the system, would require at that time. But you can, if you're relying on the heat pump as your sole source of heat and you're using it when it is really cold out, you're going to see that impact on your electric bill. What you need to be considerate of is, how does that compare against what you were getting for or paying for fuel to heat during those times too. That's where that chart that I shared at the beginning of equivalent, amount of BTUs per fuel type, and you start to see, you have to look at comparatively against your bills to determine what the real cost is of operating that heat pump, because you'll see an increase in your electric bill, but is that being offset by the fuel you're not burning? And that's where you have to look at the data to define, is this right? How much do we want to rely on it? Do we use it when it gets really cold out?
thank you very much, Steve. I'm gonna go on to my piece because I want to make sure we have time for question and answers at the end. So, what should you do if you think it's time to upgrade your home? Uh, First of all, call us, Efficiency Vermont. We can help you figure out your next steps, the rebates you're interested in, and any other details. If you're looking for a deeper understanding of your home, schedule a virtual home energy visit. A lot of folks in the questions had some very specific questions, and that's what those virtual home energy visits are for. It's a 90-minute virtual one-on-one video chat with an Efficiency Vermont energy consultant who will answer questions, look for places your home is losing energy, and suggest improvements. If you have natural gas and are a Vermont Gas Systems customer, call them and ask about a home energy assessment. Next slide, please. Efficiency Vermont has rebates for heat pumps, heat pump water heaters, and efficient wood stoves. And a few are listed on this slide. You can learn more about our rebates at efficiencyvermont.com/rebates. Next slide, please. If you want to go deeper into buttoning up your home, we have two more Weatherization Wednesday webinars this month. On the 22nd, we'll go more in depth on next steps for starting a project and details on rebates and financing options. And on the 29th, we'll go deeper into heat pumps. A lot of people had heat pump questions. You should come to this one. And as a reminder, register for these webinars to get a recording of the presentation. You don't need to watch them live at noon, and you can register for them at buttonupvermont.org. Next slide, please. Thank you for joining. Any questions? Next slide, please. And next slide, please. And before
Uh,
you go, please take a short survey. Next slide, please. Thank you. And we really want to know how we did, if because it helps us design these in the future. So ask any questions in the chat or the question and answer. We have about 6 minutes left. Thank you, everybody. This has been a great set of questions this time around.
Great. Is there anything we can address for questions, Bruce? Kind of just rolling through what I'm seeing in the chat here now. A lot of them looks like you've been busy on the keyboard, Bruce.
Well, it's interesting, Steve. I want to listen to you, but I'm trying to answer questions, and it's it's a it's multitasking at the maximum. But
100%, yeah.
yeah, yeah. So someone just asked about VSG and Burlington Electric. VSG has their own program. They're similar to ours, same sort of contractors. You can get to that they have links online. You can actually do a virtual home energy visit with us through we work with VGS customers there, but we refer them back to their program incentives and stuff. Um, and I guess Burlington Electric works with us. Is that correct?
For rebates, Anna, you want to answer that one?
Depends. I was just gonna put a link in the chat to where you can find all of the rebates at efficiencyvermont.com. And then within each specific rebate, it'll give you directions whether you can apply through us or you need to go to Vermont Gas or Burlington Electric. A lot of Burlington Electric rebates you can apply directly on their website.
Okay, I just had a question. Maybe you guys saw a different type of refrigerants and heat pumps, and they're requesting your answer, Steve.
What was the question?
Please discuss the types of refrigerants in heat pumps.
Types of refrigerants. Well, the 454B, I believe, is the type that is now being used in equipment. There was a federal standard put in place last year that required what had been R410A refrigerant was the common type used in most heat pumps. That was banned at this point. You can't use it anymore in refrigerant equipment because of the impact of HFCs, hydrofluorocarbons. And so these new refrigerant types that are being used, commonly used, have a lower potential for greenhouse gas warming if the refrigerant is released. There are differences between refrigerant types are the capacity of the refrigerant to extract heat energy at a broader range of temperatures, at lower outdoor or ambient temperatures. That's a difference between the different refrigerant types. The heating carrying capacity of the refrigerant too. Different refrigerant types can generate more BTUs or more heat, so create higher temperatures in the heat pump. And there are other what are considered legacy refrigerant types or clean refrigerant types. Most of them, are hydrofluorocarbon-based refrigerants, but then there are also the quote-unquote natural ones, which would be carbon dioxide, propane, butane. Refrigerators in our homes are often propane or butane. So there are some potential changes in the horizon with other refrigerant types coming down the road that are used in Europe or other parts of the world that we may start to see in North America and in our equipment. And those other CO2 and propane, butane type refrigerants can create, again, higher temperatures for output for the heat pump and a broader range of being able to extract heat energy. So, but they're not common yet. Some of the R32 carbon dioxide equipment does
I believe it's
exist and
called.
is being used. But yeah, that's kind of the landscape of refrigerant types and how the differences between them.
And we had a person ask if these are toxic to the environment. I know that some of the newer refrigerants have a lower impact on,
Yeah, it's the global warming potential of the,
yeah.
refrigerant if it's released. I mean, that's the other part about this too, is that refrigerant systems are designed to be closed loop. And, you're literally a refrigerator and or freezer. It's a closed loop refrigerant system from the factory. And it's just there shouldn't be any refrigerant leaking out of a system. If there's refrigerant leaking out of a system, then you have a problem with the system. And that's a factor when we talk about how we use heat pumps for space conditioning,
As long
is
as it's cold
because you
enough
have
to
to
handle.
connect equipment. You have to make a refrigerant connection between the indoor unit and the outdoor unit. And those are the times where refrigerant can be leaked, or it can be just vented to the atmosphere, and that's something you're not supposed to be doing, shouldn't be happening. So yeah, the concern of the refrigerant is really about its potential for being released into the atmosphere um, during installation or maintenance.
So you guys are seeing these questions about service, correct?
Haven't seen them yet as I've been
Okay.
talking, but
So someone's asking, how often do heat pumps need to be serviced, Steve?
sure. Uh, there is some maintenance. It's just like any type of appliance. They do need some maintenance and cleaning. If you have a ductless wall-mounted unit, there's a lid that you'd flip up on the front of the unit, and underneath that, you're going to see a filter that is meant to keep debris and dust and dirt out of the refrigerant coil below that. So those filters need to be checked on a somewhat regular basis. It depends on your home, but they should be checked at least every few months and cleaned to keep uh, dirt and dust and debris out of the refrigerant coil itself. If there's a lot of debris that gets to the refrigerant coil, it's going to decrease its capacity for heating and cooling. The outdoor unit, similar. The outdoor unit is a huge coil of copper piping with aluminum fins surrounding it and protected by the case of the heat pump of the unit itself. That coil and that needs to stay clean and clear as well. And that is also going to depend on the conditions in your area of whether or not that thing gets gunked up. And so free air and free space around the piece of equipment outside has a big impact on maintenance. Um, you have to be careful with cleaning them when it comes to the outdoor unit because you don't want to bend or ding up the aluminum fins, which are super thin and super fragile. Because if you start to damage those, then the equipment's not going to work as well as it should. There are professional cleaners on the market or in the market. We Clean Heat Pumps is a company that specializes in doing deep cleans of the indoor unit and the outdoor unit. But you can talk to your installer as well too about any sort of maintenance plan or cycle. But compared to other types of equipment, they're pretty low maintenance.
Perfect. Well, thank you so much, Steve. Thank you, everybody. We are at 1:03, so we should go. If folks continue to have questions, they should contact us at efficiencyvermont.com. We have an email address as well as a phone number that you can call. Thank you, everybody. This has been a hop-in chat session. And with a lot of really great questions. Please take the survey, and thank you again so much for attending. Bye.
Thanks, everybody.